Hello everybody and welcome to a Microsoft Tech Days event today. We are going to be learning all about Go on Azure and we're super excited to have you here with us. I'm joined today in the Microsoft studios with Adelina.
Hey everyone!
It's great to have you here with us today and we have got a super great event planned for you for the next 3 hours. We're going to have a 10-minute break in between, but don't worry, they're just guidelines. We may not take that long. We hope not. So, let's get comfortable. Before we go any further, I'd just like to say we always have a code of conduct with all of our events. If you'd like to read this in full, please go to aka.ms/eventscoc. In essence, it is just to be aware of others, be friendly, be kind, and just be nice. Have fun as well. This is a learning environment for all, so please ask your questions in the chat, and we look forward to answering them. So we're super stoked to have you with us here today. Just be kind. Also recognize it is the start of Ramadan. So Ramadan Kareem to everybody who is practicing and following that. It's great to have you here with us. So, who are we? My name is Liam Hampton and I'm a Senior Regional Cloud Advocate here at Microsoft and I work really closely with the Reactor in London. And as I said, I'm joined here with Adelina today. Tell us a little bit about yourself.
Hi everyone, my name is Adelina. I'm a tech evangelist at Form 3. I've been a golfer since 2018 and I've got a background in Java as well. So today I'll be explaining some of the things that I learned about Go and I hope you're going to find it really interesting.
Brilliant, thank you. So tell me quickly, before we move on, you came from Java. How did you find it transitioning over to Go?
Go is a lot simpler and a lot less verbose, while still staying very specific and statically typed. And we'll demonstrate that to you today. And I definitely don't imagine ever writing anything else other than Go.
It's a brilliant language, and I'd just like to mention the community as well. The community is second to none all around the world. There's some fantastic conferences, meetups, and people in general. So it's great to see that you come from Java, and it's great to see that there's some similarities. And we just look forward to exploring them.
Liam, you forgot to introduce our two friends.
Oh my goodness, yes I did. So we have got the Gopher, which is the Go mascot, and we have got the Azure Bit, the raccoon mascot for Azure. So what have we got in store for you today? Well, like I said, these times are just a guideline only. So we're going to start with our introductions, which we've just done, who we are, what we do, and where we came from. Next, we're going to go into the fundamental concepts of Go. So we're going to look at the semantics of the language. We're going to look at how it flows, different typing that you have, and just some general understanding to bring everybody up to the same level. And Adelina is going to go through a really comprehensive list of all of these things over the next hour. Then we're going to jump on and see how all of that translates into Microsoft Azure, how and why we use Go in the cloud, and some of the services that are written in it, and some of the services that you can use too. Then we'll have a quick break, so put your feet up, or go for a walk rather, and grab a drink, have some fun, come back, and we're ready to rock and roll with the next part, which is a live coding session. We are going to go through a 3-tier application that we've half deployed to Azure. It's broken at the moment, but we're going to fix it. And then we're going to wrap up with some Q&A. And that's where we're going to have you ask us the questions that is burning in the back of your mind that you want to get to know and have us answer. So
All right. Sorry.
Yeah, so sorry, with that, we'll hand over to Adelina, where we're going to be talking about the fundamentals of Go and its concepts. Hand it over.
I was too keen, I started early. So yeah, the purpose of this section is not to teach anyone to write Go from scratch, but just to revise some of the concepts that we'll be covering and using today. And we hope that this is a useful refresher to maybe those that don't work with Go every day, but have taken the tour of Go or know some of the basics. However, I hope you'll find it interesting. So the first thing we need to know is that Go is strongly typed. And it was designed with simplicity, safety, and speed in mind. At all points, we know the type of our variables, and Go uses type inference to make the code less verbose and infer the type of the variable based on its value. The Go toolchain builds and runs our programs, and all runnable programs must have a main function defined in a main package. And we'll see that in a moment. What you see here in the code demonstration is type inference in action. The shorthand operator is the colon equals, which initializes a variable and immediately assigns it the value on the right-hand side of the colon equals. So what you see here is x is of type int and has the value 42, y is of type string and has a hello world, and v is of type slice string. A slice is like a dynamic array, but we won't be going too much into collections in Go. For all you need to know is that it's an array that automatically resizes with its elements. So let's have a look at some code. This is our first runnable program. What you see on line 6 is the second way we can declare variables in Go using the var keyword. And when you use the var keyword, there's no value to infer the type from, so this is why it's followed by the string. On line 7, we see the same slice, Adelina and Liam, and on line 8, we format a string based on the host's values that we've declared further up. And finally, we print it out on line 9. And the reason you see that on line 8 we don't use the colon equals or the shorthand operator that we saw before is because greeting has already been declared and initialized by type on line 6. So let's see this in action. So in the fundamentals folder on our repository, you'll see different directories that contain all of the things we'll be running today. So this one is in the strong typing directory, so I'll run strong, and we will run main.go. And what you see here is the go run command, which builds and immediately executes the program that's just been built. And the output is, hello friends, we're Adelina and Liam. What a wonderful way to start.
That is a brilliant way to start, especially when we're looking at the very basics of a language. And it's basically the hello world, right? This is what it is.
Yes, just with Adelina and Liam.
Exactly.
All right, so I'm going to go back to our slides and let's continue our exploration. We also have functions, and Go declares functions using the func keyword. Funky. Go has native support for functions, so they are treated just like any other types, and they can be variables, return types, and parameters that we can use for later invocation. Unlike other programming languages, Go doesn't support function overriding. So names, as what they are called, names must be unique within a Go package. Another thing that we have is deferred functions, which are guaranteed to run after the surrounding function has completed, either through an error or through successful completion. And function composition, which is the composition of multiple functions that take in and run each other, is a very powerful tool. And Go makes it possible for us to leverage the power of function composition through native function support. Shall we have a look at a runnable example?
Let's take a look.
Don't just take my word for it. So I've written another little program. What you see on line 5 is us creating a say hi function, and it takes in a parameter with a slice of strings. And what you see inside the body of say hi is exactly the code that we've seen before, so let's not use more time discussing it. On line 12 you see a deferred function, and the deferred function is inside the scope of the main function in this example. So what you see, the defer will run after the completion of our main program. Inside the main program, we simply invoke say hi and declare our hosts Adelina and Liam, because we're always here for you. One other thing to mention is that we invoke the deferred function using the round brackets on line 14, and that's really important because otherwise the deferred function will never be invoked. Should we have a look at what will happen?
Let's take it away.
So if you were to guess, Liam, what do you think will happen once I run this?
I would guess, now this is going from my knowledge of defer and how defer works,
Yeah.
but that would run at the end of the function execution. So it would say, hello friends, we're Adelina and Liam, goodbye friends. So it runs in reverse order.
That's exactly what's happened. So you were correct. I was just quizzing and keeping it on his toes. So exactly like what we expected, we say hello and then goodbye due to the magic of deferred functions. And I think they're very, very useful, and we should learn to take advantage of them more in our code. All right. So error handling. Unlike other programming languages, like my good friend Java, error handling is explicit in Go. And what that means is that errors are a type just like any other, and they are returned and handled exactly in the same way as we would any return value. The zero value of the error type is nil. So if you have a nil error, that usually means that our function has executed correctly. And errors should be handled first, keeping code minimally indented. So we say if the error happens, return, while the rest of the code in the successful path will stay indented outside the scope of the if condition. What you see there also is how to create a new error with the errors.new, which is then taking in a error message. So let's have a look at another example, because I've prepared examples for everything that I'm talking about today. So what you see here now, in the case of empty hosts, we return an error because we forgot to pass our names. Aren't we silly? And inside the main function, which starts on line 18, you can see that there's still the defer that we'd done before. And on line 22, we check if an error is happening. And in this case, it will happen because we've passed an empty slice as the parameter to the say hi function. And in that case, we will immediately stop execution with the fatal log.fatalf. Another thing to mention here is we see that the error parameter, or the error return value, is declared inside the scope of the if condition. And that allows us to keep the scope of the error to the if itself. And if there was an else, of course, that would also have the error available to it. And this allows us to avoid leaking state outside the scope of the if. And I think it's very important that we keep this in mind. How much do I need the variable? And always keep it as low and tight as possible. So let's have a look at how it will look. So I'm going to run again, this time with our error handling main.go. And what you see here, there was an error, something happened, and then the fatal exited. So that's error handling in a nutshell. What we then see, Go is not an object-oriented language, as it doesn't support type hierarchy. So we can't say like user extends person or anything like that. But we do have custom types, which are declared using the struct keyword. And structs are just very, very simple collection of fields, and they also support method creation, methods declared on them. You don't have to initialize all of the fields inside a struct, and if you don't, then that field will assume the zero value of that type. In the case of string, the zero value is the empty string. And unlike other languages, Go doesn't force the creation of constructors, so you will have to create your own, like what I've shown here with the new person function. And it's just a constructor, it's just a function like any other, except that it returns an instance of the custom type that we were talking about. So let's have a look at that in action, perhaps with the specific hosts that we've been looking at so far. So on line 5, we declare the type host, and it has a field name. And what you see on line 9 is the declaration of our first method. And the way you do that is with the declaration of the receiver. What you see is h host, that's the receiver of the method. we can treat the receiver as the implicit first argument of the function, while at the same time, this function can only be invoked once I have created a host. The main function has been changed a little bit. So on line 14, we now create a slice of hosts, no longer string, and we pass the name of the host in line like you see on lines 15 and 16. Then on line 18, we loop over the hosts and invoke the say hi function. I'm going to run this one more time because we have been making some changes, but once it becomes more less interesting, then I'll stop doing all of the running. So let's run on the structs folder, main.go. And what you see here, now we each say hello with our own greeting. And we've just created and used our first custom type.
That's brilliant. Now, I have a question.
Tell me.
Where do you think you most use structs? In what kind of data representation do we see this a lot? Or do you use it the most?
When I need to, so it's all good and nice to use inbuilt types, but when we build applications, it's not nice to keep running around with the primitive types. So in most code bases that I've been writing code in, I have seen structs extensively used. And another thing that they're useful for is for wrapping dependencies. So if a host needed another service or another kind of something else other than a field, then I would save it there and initialize it with a new function, ensuring that a type is there when it's required for later invocation.
Nice. See, it's really fun to see where these kind of data types or this kind of organization is used within a program. Now, personally, I see this a lot happening with JSON data, and I see it happening when you're unmarshalling and marshalling JSON for APIs. We'll be showing you a little bit about that later, but in terms of that's where I see it the most, and it's really important and really quite good to understand and see this happen. Thank you for showing that.
Yes, we'll have a look at these are just the fundamentals. We'll be exploring them later in the live code as well.
For sure.
All right. So the next thing we discussed, I already alluded a little bit about the package, but I think it's important to understand visibility in Go because there are no modifiers or visibility modifiers that are declared explicitly on your functions or types. Instead, by default, the visibility of your variables, types, and functions is inside the package scope. Like we saw before, host was only available inside the package that was declared. And a folder can only contain a single package, but the package doesn't need to be defined after the directory. So what we see on the picture is a typical skeleton of an application in Go. You might have a Docker file, you might have a make file, and then multiple directories which will contain their own packages defined inside them. Encompassing everything, all of the packages, is the Go module, which we define with which is defined with the Go mod file. And all of the packages that we later declare will belong to that module. But it doesn't matter whether you're using a package inside a module or outside the module, it will always be imported using the full module/path. So for example, if I wanted to use something inside the service package, I would declare module/service. And again, we'll see all of this explained in much more detail later on. I want to show you one last thing about visibility, so I have prepared a little example to show you. If you want something to be available outside of scope, then you have to capitalize it. But inside the scope, inside a package, you can only have a name can only be used once. So for example, what you see here is if I were to uncomment this function, it will cause a compilation error. Do you want to hazard a guess why, Liam? Oh, sorry, I uncommented this one.
I'm actually going to leave this down to the users. I want people to put in the chat why they think this might fail.
The compiler will help us because in Go, the compiler is our best friend.
The toolchain.
So if we hover over this, you see that you have a field and method using the same name. So what you see here is name is hovering over this name field. So this is what we mean, that names can only be declared once inside the package. So I'm just going to comment this back out because I don't want to see any compilation errors when I'm running this later. But I thought it was interesting to mention other programming languages don't have this problem, and I just wanted to highlight it to our listeners.
Certainly, it was one of the things when I was beginning to learn Go, is understanding the visibility of functions and your exports and circular import errors that I was getting and how it all sort of came together and works together as one. So this is certainly a fantastic place to start learning if you're at that early stage of learning Go, purely because it tripped me up, and I remember spending so long trying to figure out my errors and understand what was actually happening at that point.
And remember, the compiler will help you. So these are the fundamentals that we've covered. So let's begin to look at more interesting things. And one of the things that is, I think, a very powerful construct in Go are interfaces. And they are kind of like similar to structs. So structs were a collection of fields, while interfaces are a collection of method signatures. And there's no implements keyword or anything like that in Go because the compiler automatically will check if your struct is satisfying the interface and cast the concrete type to the interface type. And they are the primary way of implementing polymorphism in Go. What you see here on the side is we declare the interface called user with the interface keyword. So that's, instead of putting struct there, we've put interface. And inside we declare all of the functions or methods that belong to that interface. Further down, I declare a person struct, and the person will automatically implement the user interface because we have defined a method that satisfies the click method signature and attached it to the person type. So that's as easy as it is to create interfaces in Go. Let's have a look at what we can do with them using our theme that we've been using so far. So now I have an exported host interface that says hi, and I've declared now two types, one experienced host and one host. Now we know that slices are strongly typed, so the experienced host and the new host are different types and wouldn't be able to be saved in the same slice. However, this is where the magic of interfaces comes in. What we see on line 26 is we declare a slice using the interface host with the capital that we saw earlier on, and now we are able to save the both instances of new host Adelina and the experienced host Liam, and they can be saved in the same slice. This is a very basic example, and there are many more useful usages of interfaces. But most often, interfaces wrap around dependencies, making it really easy to either change your dependency at a later time or put a mock in and be able to test your code without it ever knowing what's happened.
Exactly. That's one of the powerful things that we have with interfaces, especially when you're testing RESTful APIs, because you don't necessarily always want to make that call, but you do want to mock the return of the data. So it's a really powerful way to start using this in tests, to start using it in your production programs.
That's tests. We will cover tests in a little bit, so we are digressing. But tests need to be very quick and cheap. And if you're doing a whole bunch of like external calls and relying on real things, then you're not going to be able to get the speed and feedback loop that you're looking for.
Well, there's that, but there's also cost optimization, right?
Yes.
If we're thinking about cloud sort of expenditure, if you're mocking a test, it's way better than always going out and calling your service, especially have databases which are expensive to run.
Yeah, well, we can continue because even though if you're relying on an external dependency, then you also might have a failing test because of something that's out of your control. So yeah, always use write your tests separate from your external dependencies. But yeah, I think that's really funny. Like, we immediately went to testing. Okay, so another really cool thing in Go, and I think many of you have heard about this before, is the way that it handles concurrency. And the main thing, the main construct of concurrency is the Go routine. So I just wanted to show you very quickly how to use them and what they look like. So Go routines are sometimes known as lightweight threads. They run functions concurrently inside our Go programs, allowing us to make the most of our resources and run things not at the same time, but be able to park tasks that are not able to complete and then continue running something else. And so far, we actually have seen a Go routine, and that's the main Go routine, because the main function starts its own Go routine, and then everything that you're doing in your program is actually running inside the main Go routine. Once you start a Go routine, you do so with the Go keyword, as you can see here, and it is followed by a function invocation. In this example, I have used an anonymous function. Starting a Go routine is non-blocking by design. Otherwise, we're back to doing things sequentially, and you can't schedule something else that can run because you're waiting for this function to complete. So what you're seeing here is one of the number one mistakes that people make when starting out with Go routines, which is not blocking the main Go routine. So actually, you're never going to see this printout in this example, because the main function will start the Go routine, which is running that small function that you see there, and then immediately terminate, killing its child Go routine, which is really sad. But at the same time, it won't have, this will happen much quicker, and we won't have time to be scheduled and then print something to the terminal. So you're never going to see this printout to the terminal. So let's have a look at an example, maybe looking at our hosts and what we've done there. Sorry, I'm having a hard time finding my example. Do you see concurrency somewhere?
Go routines.
Up one. Sorry, I lost track. Okay, so we have the experience in the new hosts like we've done before, but now they're going to say hi in a Go routine. So what do you think will happen when I run this, Liam?
Well, it should say, hi, I'm Adelina, and hi, I'm Liam.
Let's have a look if that happens. No.
It's wrong.
So what's happened is exactly what I was talking about before. We haven't blocked our main Go routine, and now I've demonstrated to you that you're never going to see this printout. So our Go routines start up, they never have time to print to the terminal, and then the main Go routine shuts down and kills everybody. So we need some synchronization mechanism. And the way we usually synchronize and pass information between Go routines is through channels. And I think channels are one of the coolest concurrency constructs, really. There are locks as well, but and other synchronization primitives, but I won't be covering them in this. So what you see here is channels are pipes that allow us to pass information in a thread-safe way. And unlike the Go routines, starting Go routines, operations on channels are blocking. So channels have two main operations, which are sends and receives. So when you send something, you write this value put it on the channel, and when you receive something, you read the value from the channel. So the two counterparts in a channel operation are the sender and the receiver. I used to say reader and writer, but which I think is understood as well, but they are called sends and receive, so it's important, I think, to get the terminology right. What you see on the code example is the way we create the channel first and foremost with the make function. And the make function will create, it will initialize all the synchronization mechanisms and everything under the hood and return you a channel. Another thing to note here is that channels are represented by the built-in chan type, which you see here is CHAN. When you send to the channel, you do so with the operator that looks like an arrow. So in the first example, you were writing the value hi to the channel, and in the second example, we're reading from the channel. One thing to note is that channels are tied to a data type. So when I declared the channel, I said the data type of this channel was string. So I can't be writing integers or something else in it. So they are typed, and this runs along with the type safety that I was talking about, the strong typing in Go that I demonstrated earlier. So let's have a look at another example. So everything is a running program. At the top, I've changed our experienced hosts and all of that. So what you see here is that the signature of the host interface is now taking a parameter, a channel parameter, as a channel as a parameter, sorry, channel parameter. And we will be using it to pass information back to the main Go routine, because that's what they do. They synchronize and pass information. So on line 14, I format my message and I write it to the channel. And I do the same thing for the new host on line 22. Now, inside the main function, I create the channel that will be used, and all of the other initialization is the same. There is one extra for loop on line 34, which receives the values from the channel and prints them to the terminal. And the last thing we see is the close operation, which is also supported on channels, and I haven't discussed it. But basically, the close is signals to receivers that no more values will be sent. And if you try to send to a closed channel, then that will panic. So let's have a look if we fixed our timing issues that we had before. So I'm going to go run channels main.go. So what you see here is the printouts are correct, but actually, if we look back, you see that Adelina is created first and Liam second, while on the printout we see Liam printed out first and Adelina second. Do you want to hazard a guess why?
Oh, I'm going to say this is because of the blocking of the Go routine, and how its sort of method is put out in a sequential order, or not a sequential order, as should we say.
Definitely. So the Go routines, even if we start them with Adelina first and Liam second, they will run when the Go scheduler tells them to. So the orders are not guaranteed in the current world. And that's something we should always remember. So unless you've synchronized it, it's gonna be out of order. If I wanted to run in a particular order, then I would need to use another synchronization mechanism.
We have to specify it. Now, before we move on to the next one, can we just take a moment to have a look at the syntax that we're using here with the arrows? Can you help us explain what these arrows are doing? Because I don't often see these in other programming languages as explicit as this.
So the arrow is the channel operator, and its direction helps us remember which operation we're performing. So in the first example, which is the send to the channel, the arrow points towards the channel, so the high is being sent to the channel. I almost said written. In the second example, the arrow is pointing away from the channel. It's on the left-hand side, and this means that we're receiving from the channel, taking the value away. And one thing to note, which I forgot to mention, is actually that messages are only read once from the channel. So you can't, if you write a message, it'll only be able to be received by one receiver.
That is a really important sort of point to understand, especially with the visual cues that we're actually getting from the syntax now. And this was part of Go itself and why it is here. And we will move on to that later. I'll discuss a little bit as to why. But I'll hand it back over to you.
Ooh. One other flavor of channel is the buffered channel. So the channels we've seen so far have been unbuffered. That means that they cannot hold values. They don't have any capacity to hold a value until someone is able to receive it. So in an unbuffered channel, both the sender and the receiver need to be present and ready in order for the operation to complete. Sends and receives are synchronous in unbuffered channel. However, buffered channels can be initialized by passing an extra parameter to the make function, and then they will have a predefined capacity to save values for a later time. And what you see here is the asynchronous nature of the operations on buffered channels. So what you see is that the send operation is happening with the right value operation, and then the sender is unblocked and resources can be reused, while the receive operation is happening at a later time, at time 2, so where we get the value and receive it, send it to the receiver. And this is another way that we can use channels. In this case, we will have asynchronous operations on buffered channels. So we'll have a quick look at them just to show you the syntax again. And what you see here is that the channel on line 25 takes in the second parameter, and this time it'll be of type of size 2. It is often used, buffer channels are often used with worker pools, because that gives us the opportunity for all of our workers to write their values and be processed at a later time. But in our case, we will see the same output, so I won't run this again.
Exactly.
So we're really going into the meat of concurrency now.
This really is.
Yeah.
So we've kind of covered from the very basics of Go, understanding variable declaration and structs, all the way down into buffer channels and things that you, as a new person to Go, you may or may not use this straight away. I know I personally didn't actually use Go routines until about a year after using Go. And even then, it wasn't really for anything substantial. I think I was doing some port scanning and sort of going over some, ports and seeing which ones are free and which ones are not. But I didn't want it to be blocking every time I was checking a port on a thread in my machine. So you can see you're really getting into nitty-gritty parts of Go here, but it's important to understand these parts just as important it is to understand the fundamentals, or at least understand the basic concepts of what's going on here. Now, some might say this is memory management to an extent, and especially we didn't really mention it with the defer function or the defer keyword, but that is very much memory management to stop you from leaking your threads or stop you from leaking data with connections that you may or may not leave open. But you're doing an absolutely stellar job. This is brilliant. Even I'm learning some things here.
Oh, very high praise. One thing that I would like to mention is that if you're going to start using concurrency and you're going to do it in Go, you're starting out with your Go routines, use channels as well, because more than likely you're gonna have to pass the result of something you're computing, and I actually think they make things a lot easier than using locks, which is something that I was used to from my Java days. Okay. So we've already jumped ahead on testing, but I want to, this time let's have a look at how it's actually implemented. So Go has a testing package, and it's called testing, and it's included in the standard library, and it allows us to write tests, verifications, and benchmarks. And benchmarks allow us to test the performance of our code, which I think is very, very important and sometimes overlooked. We think about only functional testing, but actually if your performance is really poor, that's really not going to be a good user experience. Nobody's going to use that. So tests have the signature that you see on the screen, so they must start with the capital test. And then you can write, I think it's called camel case. You can write the unit under test or whatever you're testing, give a name to the test in camel case. Tests only take a single parameter, and that is the testing.t, a pointer to testing t. So you must have this signature in order for the test to run. Inside the test, we can write assertions and do all of our verifications, but Go also supports subtests, which you see here with t.run. When you write the subtest, this allows us to really easily write table-driven testing, which is a very popular technique. And it also allows us to group together maybe a whole bunch of setup code and then run multiple scenarios. The way you run tests is again with the Go toolchain, and instead of doing Go run like we've done before, you write Go test, and there are different ways that you can run tests, but what I've included here is how to run a particular test with the -run. And if you want to run all of the tests in all of the folders, then you do Go test and // and then the 3 dots, which is the ellipses. Yep. One thing to note, that it doesn't matter how well you tested concurrent code, you cannot prove the absence of bugs. You can get some statistical confidence, but you can't say this concurrent code for sure doesn't have a bug. And the reason that is because when you're leaking variables or incorrectly synchronizing your Go routines, that's actually a design failure. But at the same time, it's good to test concurrent code at scale as well, which you can do with Go routines. So Go routines integrate well with tests as well.
They certainly do. Testing is one of the most important parts of writing production-grade code. I myself am an avid advocate of test-driven development. It's been ingrained on me ever since I brought a production machine down and didn't write any tests. So ever since then, I've taken a step back, and I always write my tests first. Now, I always have a saying, your code is only as strong as your weakest test, and that is kind of what you're alluding to there with concurrent testing or concurrent code testing. It's brilliant. Now, you've got some fantastic examples here to show that we've been running through, and testing, just want to drive that home. In Go, it is fabulous. I mean, from the get-go, Go has got all of these brilliant things built into it straight away, right? So you can test your code with packages built in. You can test it with third-party packages as well, can't we? And it's really visually appealing for you to see it and understand what is test code, what is a test file, and what is not. And it's very, very visual, as you are seeing, with everything that we're doing, from file names to function signatures to even the syntax that you're writing.
Yes, test code is lives alongside the source code, which I forgot to mention, even though it's on the slide, and it lives in _test.go files. So I think they really serve as well with as code documentation. If you have a really well named test suite, a really well structured test suite, then newcomers can just go and inspect the tests and really see how is this thing supposed to behave, as opposed to reading a whole bunch of code which maybe isn't like dodgy, right? So let's have a look at very quick example. I don't want to. So what I've done here is I've redefined some of the test targets only because I'm writing things in a different in a different directory and in its own file. But what we see here is a table-driven test. So what we do is we declare an anonymous struct which contains a name for the test, a name for the host, a host, and a want. So it's what we're expecting for the it's what we're expecting from the case that we're wanting to run. And immediately after on line 33, we declare our test cases. So first we have a new host and then we have an experienced host, and we say here what it's supposed to, the want is the expected value. So we run the test cases in a loop, and we try to test the concurrency, and you run the say hi function in its own Go routine, which we can scale up or down however we want. And then if the greeting is not what we wanted, then we error the test case out. So yeah, do you want to try? We can try and run it and see
let's
what
try.
happens.
Let's try and run this test. And
so
see what happens.
I'm gonna try and test it with this So it should be able to detect the file so that's the unit test that's run. So what you see here is we don't have test files for all the other all the other folders that are inside this fundamentals. But if I run the same with the -v, that stands for verbose, and you can see here the way that the output is actually running and how nice it is. It's exactly the structure that Liam was talking about when you're running your tests.
It's always great to see this in your terminal. It really is. And it's nice that we've got different outputs, especially. I mean, this makes a real difference when you're looking through a CI/CD pipeline, for sure. Because obviously, if you're running these test cases in your deployment pipeline and you just get the spit out of the first one, which we can see on the screen at the very top, it doesn't really tell you much. It tells you that, yes, that file had all of its tests pass, but it may not depict it to which ones.
Yeah.
So if one fails, it could just say fail, and you'll get an error, but maybe not the most verbose one. So the -v is, in my opinion, I always put that on all of my tests. Every single time I run tests, regardless how long it is or how big it is, I will always put a -v. It's a really cool tool.
And we haven't included tests because we were doing things just to explain the fundamentals, but always test your code exactly like Liam says. We are almost at the end of our fundamentals exploration, but I don't think fundamentals of Go is complete without an introduction to the net HTTP package. And this is one of the most popular and acclaimed packages in the standard library. So it allows us to really easily start servers and serve requests and responses. What you see here is a typical flow. So the client will send a request and the server will be built with the net HTTP package, and then they might call out to a different server, which they might or might not use HTTP for, and maybe that service will read from the database, and altogether the response will be sent back to the client. You don't have to use JSON. You don't. But it is the standard when it comes to HTTP traffic. And we'll be using JSON in our example, and we'll be looking at exactly how that works as well. The way that it works in Go, the net HTTP package serves HTTP routes using handler functions, which we'll explore in a little bit as well. And we also have response writers and requests in order to write data that will be returned from the handler. So let's have a look at a very simple example. We will explore this in more detail in our hands-on section. So on line 10, you see a handler function. It takes in a response and a request. So the request is what you received from the client, and the response is what you will be writing as your response to the client. When we start a server, we always do this in the main function. And that's exactly the same as what we've seen so far. It's like nothing is special about running a server in Go. What you see here is we register on line 16, we register the handler function to serve the root endpoint, which we just specify with the forward slash. And later we write a log line on line 19, which says what port we're listening on. Then we use the listen and serve, which is a blocking function, which under the hood invokes the net HTTP package and is able to serve set everything up so that you're able to send requests and it can respond. So these are all the lines that we need to start a server. In the case that the listen and serve returns, because probably the server's been killed or something's happened, so that listen and serve will block while the server is alive. We simply write a fatal error to the terminal and then finish the execution. So I won't run this right now because we will see it in action very shortly, but I just wanted to touch upon the fundamentals of what a handler is and exactly how to start a server. And you said it's enough characters for a tweet or something like that?
Yes, 100%. A really fun fact, actually. Well, at least it used to be a fun fact until I think the character limit changed on Twitter or is changing. You actually can write a HTTP function or HTTP server in the character limit of a tweet. Now that says a lot about the language itself, not just the underlying underpinnings of it, but in terms of usability and how much of you as a developer can spin these sort of, I say, projects up, or maybe a Sunday project really quite quickly. And a lot of the cloud native tools are then built around that. And that is just one of the key stepping stones when it comes to building a language or running with a language and using a language like Go.
And a lot of people say that the net HTTP package is one of the reasons, and of course performance, is one of the reasons that Go is mostly used for running web applications. So this brings us to the end of our fundamentals. I hope you've enjoyed it, and I hope it's set you up for success for the remainder of the session. But I will now hand over back to Liam, who will tell you more about Go and Microsoft Azure.
We will do indeed. But before I get into Go and Microsoft Azure, just going to head over to the chat and see what we've got going on. I hear it's very, very active. It's fantastic to see this. Now, I'd just like to say Ken Yup and Rogue Travel, thank you very much for the great conversation that we're having on YouTube. It's absolutely brilliant to see that. And of course, our moderator, Arthur. Now, I believe we've actually answered a bunch of questions already in the chat, but what I will do is take a little break for a second. Now, let's talk about the fundamentals of Go. We've come right the way from semantics and understanding of the syntax, right the way through to what you can do with it in terms of testing, the toolchain, benchmarking, packages like NetHTTP. Now, you're 100% correct. People do choose Go purely because of the HTTP package. I've spoken to developers that have chosen it over other languages because of this. Now, you'll also see a lot of third-party packages on top of the NetHTTP package, which is absolutely fantastic to see. So they are expanding and taking this language further, an already brilliant language as a foundation, and just taking it one step further. So an absolutely massive thank you, Adelina, for running us through all of that. That was brilliant. I've learned some things as well, especially with buffered channels and understanding blockings and Go routines. Like I said, it's not something I use every day as a Go developer. It's something which, I would if I was writing production code, but as an advocate, that's not something that I do every day. But it's always good to understand and be able to teach about, because when you're teaching, you're also learning, as I'm finding out. So with that being said, I guess we've kind of been going for about an hour now. Now I'm going to run over to the slides and let's talk about Go and Microsoft Azure, because it's all wonderful saying or talking about the language itself, but what about cloud service providers and what cloud service providers are doing for us as developers? So why would you use Go in the cloud. Simplistic syntax is what we've kind of alluded to already, and we've kind of spoke about this in terms of being visually appealing, quite, I say, easier to migrate to Go from other languages, or at least understand. I know developers that write JavaScript every day and can write Go every day, side by side, because it's very, very similar. You have similar sort of methods or way of thinking in terms of asynchronous execution and Go routines. So it's all very much there for you. Not to mention that Go only has a really small number of keywords. I think there's 25. At least that's a statistic that I could find. It is designed to be easily read and understood. That is what I'm trying to tell you here. Secondly, the rich standard library. Like I said, we've kind of covered quite a bit of this, but in terms of what's available for a developer, there's so much you can do. It's incredible. Thirdly, the cross-platform compatibility. This is a real pinpoint and a really good green flag for developers. Because if you're writing a program and you want to write it for Mac OS, and you want to write it for Windows, and you want to write it for all these other lovely different flavors of Linux that you're going to find out there, you can do just that. Now, Go actually supports a lot of different frameworks and architectures straight from the get-go. So I can build a Windows executable binary from my MacBook. Pretty cool, right? Imagine if you're testing your code or you're running it and building it in a pipeline again. If you want to run it in a container of Linux, you can do that. If you want to run it in a container with Windows or a server, you can do that. So the cross-platform compatibility is a massive green thumb and a good, or green flag, and a big thumbs up, rather. Performance optimization is, again, another really good point about Go. Because of Go routines, because of channels, because of the memory management and the garbage collector that we haven't really mentioned, but is there, running around after you, freeing up that memory, it is really good at performance optimization. This makes it perfect for containers, which is your minimum viable operating system, a package of code or package of your code. So when you're talking about performance and you want it to be cheap, we're not just talking money, we're talking memory, CPU utilization, and how that runs in a remote environment that may have constraints that you won't have on your machine. And then finally, scalability. You'll often see this, Go is the language for cloud. You'll see this a lot, purely because it's run a lot in containers. We've said why, but in terms of scaling, if you're using something like Kubernetes, or if you're using other containerization optimization tools, it is great for scaling your applications. Now don't forget, please throw your questions in the chat. We're going through them, and I'll get to the ones which I can as quickly as possible. So let's look at some of the services that you may see that are written in Go. Some of your favorite ones. Let's take Azure Go SDK, a fantastic server that we at Microsoft have, where you can create your infrastructure straight from your code. You can interact with services in Azure straight from your program. So the SDK, we've got a fantastic team that helps to build and maintain this. We've got Kyoto. Now Kyoto is a new project, and it is a command line tool that is there for generating API client to call any open API described API you're interested in, if I can get that out right. It's currently in public preview, but it's going to be GA'd soon. So that's going to be an awesome project coming out to help you with open API specs. Azure Developer CLI. That was released last year. Absolutely incredible tool, all written in Go. Now, we've kind of spoken about HTTP servers, but another really good place, and especially where I came from, I was learning Go when I was writing a CLI. A really powerful tool.
Yeah.
Right? So when you're looking at these cloud CLIs or, maybe Docker. Docker was built in Go. Everybody interacts with that one. It's brilliant. So you're going to see it used in these kind of toolings that sort of communicate with your host system at a low level. It's built to be placed at the foundation of your system. And of course, we've got Azure Kubernetes. That is all written in Go as well. I think it's widely known that container orchestration tools are written in Go. It always was. I think they came out in, 2013, 2014?
Yeah.
That's kind of when they started coming around. And if we look at Go when it was released, early tens, that kind of timing. So the adoption of Go was right from the beginning with these dev tools. And the external projects. Now, a really good thing with external projects is open source. Open source is a brilliant way if you're a developer to get involved with code. You know, your first submission could be I don't know, maybe a README, a typo change or something. But some of the really big open source projects that you're going to find available to you are written in Go. Now, let's look at some of the external projects. Docker, kind of mentioned. Dapper is another really cool project. And Virtual Kubelet. And that helps us interact with the Azure container instances. We're not going to go too much into that one, but that again is similar to Kubernetes, but not quite the same. But here at Microsoft, we do have a number of employees that are working on these projects every day as their full-time job, helping to create great projects for you.
I would almost argue that because Go is used so much, I would almost say that it's not emerging technology any longer. And it's such and aside from these projects, it's used by some amazing companies to power like huge scale. So definitely, I think it's worthwhile, if you haven't been convinced yet, it's worthwhile to learn and experiment with Go.
It certainly is. I mean, you're seeing some of the biggest companies in the world run with a language like this. I agree with you. I wouldn't call it emerging. I don't think I have for about a year or two now. I wouldn't say it's emerging. I'd say it's very much there at the forefront of cloud native technologies and building projects and production system that we have at the moment. So let's take a look at Azure itself. What systems can we, or what services can you use in Azure with Go? I've got a list on here, and we're going to run through maybe a couple of them, and then we're going to dig deeper into 3 of them. Manage Kubernetes. So we've got AKS, Azure Kubernetes Service. It is what it says it is on the tin, okay? It's Kubernetes built for Azure. It's fantastic. It's container orchestration. It is there, and it's a production-ready system for you to, or service for you to use. Virtual machines. I would hope that a lot of you understand what a virtual machine is, but it's your host machine in somebody else's server rack, basically. Now, of course, we can set this up in Azure, and you can have an image, a build image, or a system image rather, and you can install Go and have it all set up and run Go on it, and you can access it remotely. Cosmos DB. I bet you didn't see a database in there somewhere. You can talk to Cosmos DB and use Cosmos DB with Go. Now, without giving too much of a spoiler away, we're going to be doing that today. The other databases. I bet you didn't see this either. MySQL and Postgres. 2 of the biggest or most widely used databases that you'll see. You can use them. You can talk to them. You can use Go with them. Object storage. If you want to store your files in the cloud and you want to access them, of course, you can use that through the SDK as well. Azure App Service. This is a good one. Now, this is part of our infrastructure today of what we're going to be showing you with our project. But Azure App Service is another container orchestration tool. But it's a really cool one, and I'll show you why soon. And finally, Azure Functions. Now, Azure Functions is the serverless workload of Azure, and it is basically a trigger for us all. Now, we're going to dig deeper into some of those right now. But if you want a full window and you want a full view of what's available on Azure for Go developers, you can go to aka.ms/techdays/go/Azure services. Now, we'll pop that in the chat for you. And this is the screen that you'll see, this window you'll see. And this will give you the quick starts, will allow you to understand what services you can use and how to get started with them. So go on over to that one, check that out. If you're a Go dev or if you're new to Go, you've got some really good guides to help you get started with all the different services we have. So let's look at Azure Functions. What are Azure Functions? Well, they're the serverless compute platform that we have in Azure. It is event-driven for your applications. So you are always going to use a trigger, whether it is a database, whether it is a state change, whether it is a message queue. That is enough to trigger a function. Maybe logic apps, if you're familiar with those. These support different languages and frameworks. However, as you'll notice from the screen, Go is not supported. And I'll tell you why in a minute. And I'll tell you why it's also on here after. But before that, you've got different ways to deploy. You can use GitHub. You can use zip deploy. You can use FTP, for those file transfer protocol, for those who don't know. And so many other ways. It is very verbose, it is very robust, and it allows you to run pretty much any language you like. Now, I said it doesn't support Go, but that was a bit of a lie. It does support Go in a really funny way. We have a custom handler, as you can see outlined on the slide here, and that custom handler is essentially a HTTP server that you can use under the hood based on a Linux machine in Azure. So when you deploy or when you build your Go code locally and you've installed the Azure Functions core tools, it simulates that environment in the cloud. So of course, when you want to test serverless functions, you're only touching the top of the iceberg or the tip of the iceberg because you're expecting the cloud service provider to handle the rest for you. You as a developer just want to write the code. But of course, you need to simulate it when testing locally. With a custom handler, you will write your Go code, you'll compile your Go code, it will build a binary for you. That binary is then going to be sent to a system or to a service that's going to run it up in Azure for you. So in essence, we basically have a HTTP server with functions. That's really cool.
That's really cool because you don't have to configure another service that will take care of your HTTP integration, and also you have inbuilt scaling with serverless. And
exactly.
Getting that right for production and high scale is so difficult. So allowing all of the scheduling and scaling to be taken care of by Azure is really makes your life easier.
Exactly. You have scale down to 0 as well. So you have this whole cost optimization, performance optimization. You can see the pillars that we're aiming for here. Functions helps you do exactly that. And yes, you can write Go with them. That's the essence of what I'm trying to tell you here.
In the context of functions, can you tell us what cold starts are? Because I've heard about that before.
Cold starts. I have a really good analogy, and I used this recently actually. Imagine you've fallen asleep on the sofa and somebody nudges you to wake you up and say, hey, come do the dishes. You're going to be like, oh, I've got to do the dishes. And then you slowly get your thoughts together and you go and do the dishes. But if you're already sweeping and you're already active and somebody knocks you and says, hey, come and do the dishes, you drop that broom and you go and do the dishes. There's less to compute. Now, of course, as you go up the tiers or the pricing tiers in service providers, you're going to get more of this handled for you. But as you look at it, that's essentially what a cold start is. It's just that starting. Serverless functions does not mean that you're not running on a server. Okay? Serverless, you're just running that somewhere else, and it's the way that the cloud service provider is taking care of more of the infrastructure and taking more of responsibility for the underlying hardware that's being used, and you just focus on your code. So some really good example use cases. We've got IoT data. Imagine you've got lots of sensors all around you. What do? You gather all that data, but that's quite a lot for one single server to handle, or maybe. But what if you want to process that in batches? Well, you could use functions to batch them together and then send it off. You could use functions to talk to other cloud service providers as a RESTful API. There's so many different ways that you can use serverless functions. I'm just saying you can use it with Go. Next, we've got Azure Kubernetes Service. AKS, everybody's favorite. This is a production-ready service, a managed container orchestration service, rather, should I say, that we have here in Azure that you can run in production and scale up with exponentially. It's a really cool service. Admittedly, it's not something that I use every day because of my workload needs are not for Kubernetes, but I've used it in the past. This basically helps you create your scalable infrastructure. And with a managed service, this is so much easier than having to do all of that yourself. And of course, you can bring in Helm, you can bring in all these other separate sort of packages or tools for you. It's all acceptable. You can use that. It's really easy to deploy your containers. And it's really easy because it talks to Azure services, such as Azure Container Registry, Docker Hub, maybe all the other wonderful registries we have out there. You can deploy from those. And of course, it has self-healing and automatic load balancing, the important part for any scalable infrastructure you have. But hey, I'm not here to sell Kubernetes service. I'm here to tell you, you can run Go on it, and you can talk to it with Go. Now, there's a reason for this, and that's because you can stick Go into a container, and it runs really light, circling straight back to its configuration of being performant and being scalable as a language. Perfect for Kubernetes. So of course, I've got some use cases where you would use microservice architectures or you'd build serverless functions in AKS. Bet you didn't see that coming, did you? Now that's KEDA. If you've ever heard of KEDA, Kubernetes Event-Driven Autoscaling. Now that's an open source project, and of course you can go find that out if you head back to the Go service, the service page that I showed you a minute ago. It's all on there. But it looks kind of messy on the screen, right? If I look at deploying AKS, you have all these different tiers. You've got a single dollar sign all the way up to $3 signs. It's expensive. Maybe it's not what you want to do. So we've got another cool service, haven't we? One that we're using today. You look petrified when I shared that. We're using another one.
Oh, I was going to mention that our engineers at Form 3 are using AKS because it takes care of a lot of the management of the scaling of the control plane, and that makes our lives easier because then we only have to focus on running our own application.
It certainly does.
So it's definitely worthwhile investigating.
It's pretty cool, and especially if you're a Go developer or you're Go heavy, which I know Form 3 is.
Yeah.
So it's a perfect choice. I mean, if you're running in production. Now the final service that we're going to talk about today is Azure App Service. Have you used this much before, Adelina? Besides our demo. Is it just our demo you've used this for?
No, I have a lot of experience in AWS. So I've actually, for this session, I've learned a lot about Azure. So this was my first time using it.
Brilliant. Well, this is a perfect time to show you exactly how and why we can build scalable infrastructure straight from the get-go. Now, Azure App Service, I've kind of avoided talking too much about AKS because we're using this one today. Now, Azure App Service is a fully managed serverless platform that you can deploy your workloads in, whether it's a web application or whether it's an API. So whether you want something fancy on the front end or whether you just want the guts and glory from the back end. So this is a perfect opportunity to talk to other Azure App Services, services such as Container Registry. We've kind of mentioned we've got Azure DevOps, so ADO, as some of you may know it, Active Directory, and so many more. But as a new developer, this is the perfect choice to go for. Now, this is where I started when I started learning Azure a few years ago. This was the service I used, and I haven't looked back at all. Like, this is perfect for your Sunday projects, for anything you want to whip up, for our stream today. This is the perfect service. It's got auto scaling based on the app's needs. So if you are running a sale on Friday afternoon and suddenly you have 1,000 visitors to your website, well, it can scale up automatically. You don't need to tell it to, just based on your pricing tier. It'll always go down to the minimum or the lowest one, and as you get the increased usage, it bumps them up. It's exactly what we've got today, and hopefully, if there's enough of you trying this with our demo later, we'll show you. And of course, you've got the streamlined deployment process. So as we can see on the picture, we've got code, Docker container, and static web app. Now, that looks much better than the previous version from Kubernetes. This is designed to be a lot more developer-friendly and easier for a developer to use. And of course, you've got the operating system, Linux or Windows, so you've got your two flavors that you may want to use, and your standard region wherever you want to deploy it. Now, admittedly, this is a screenshot. This is not the entire page, but you get the gist of it. It's very simplistic, and that is for a reason. So when would you use this? You'd use this for your RESTful APIs, like we're doing today. You'd use this for hosting web apps and websites, like we're doing today. And you can develop and deploy your microservices, standalone services in your architecture. Perfect. So if you want to get hands-on and code along with us and see the code that we're playing with today, you can head to this GitHub repository. Or if you find me on GitHub, Liam C. Hampton /Tech Days. That is our repository. That is the code that we're using today. And we will be showing you live from that repo what is happening. Now, I'm going to head to the chat and see if we've got any questions. But I think we're at maybe, an hour and 15 minutes in? I think we're pretty much on time. That's really good. So,
and we've covered a lot.
We've
started from the beginning and gone over in the cloud as well now.
We certainly have. So we've transitioned from the language to Azure, and we can't wait to show you the demo in a moment. So I'm going to check if we have any questions, and if we don't have any questions, we'll head to a short break, and we'll be back after about 10 minutes. So let me just check the chat. What have we got going on in here? Okay, so we have a question. Will you please merge review open source contributions to Azure App Config SDK on GitHub? We have a team that is dedicated to doing all of those, but I will be sure to pass that on if you're asking for a pull request to be merged. If it's open source, then yes, we will all be reviewing. We have that at Microsoft, teams and teams across the world that do help us to review these services.
Thanks for your open source contributions. I think people who like use their time to do open source are just like heroes, and I think it's so cool.
Exactly. Open source is fantastic, and it is huge in Microsoft, especially where people like the domain that I'm in, and we love it. We absolutely love it, because I kind of alluded to it earlier.
Yeah.
You don't have to be a pro developer to contribute to open source. You can just fix some typos. I mean, I started by literally searching on GitHub for Go as a language and finding all the open source projects written in Go. And that's how I started getting into open source. And that's how you sort of build yourself into, a better developer. I didn't just go straight in and say, that Go routine is wrong and this should be deploying. That's not what we did. Started small and worked up. But yeah, we do thank everybody for their open source contributions, especially to the services that we build across Azure that help us run our services. Now we have maybe one more question that is coming through. Could you recommend a tutorial or course to start using on-hands Azure services and Go? Yes, so we have got, I think in there we also have Kubernetes, load balancer, storage DB. Would it be your repo? Well, we have got many resources. So if you haven't heard of Microsoft Learn is a fantastic place for you as a developer or somebody learning new services to go to and to jump into any tech that you want. So we do actually have some Learn modules on Go, on Azure, and admittedly some of this course material that we're going to be running through that is in sort of our stream today has been published on there or has been taken from there. So we've gone through and we found some really cool parts from Microsoft Learn. So I will drop the link or get the link over to you after the break and send that across to everybody in the chat to have a peruse through.
But we will be covering a lot of essentials today. And then based on the other resources that you mentioned, that should give you a really strong start if you wanted to start building with Go on Azure.
Exactly. But I think those are the questions so far. Now we're going to head to a short break and we'll be back in about 10, 11 minutes. So go put your feet up or have a walk rather. I've said that twice now, haven't I? I'm saying put your feet up because we're stood up. Go and grab a drink and we'll see you after the break for the demo.
See you soon, everyone.
Whether you are looking to build a new career or kickstart that new idea that you've got,
Microsoft Azure connects you with the developers and startups that share your goals.
Learn new skills, meet new peers, and discover the latest in technology.
Events are running around the clock, so join us anytime, anywhere.
Reactors are communities to connect. We want you to meet real developers and entrepreneurs just like you. Here you can get skilled up and learn from our product experts in the Microsoft Cloud and in open source. So watch us on demand and share your own perspective as we live stream in communities all around the world.
Azure Functions is a functional service or FAS in Microsoft Azure. It provides a ready-to-code environment and a easy-to-code programming model as a service solution. As a result, it helps focus on the pieces of code that matter most to you, without the need to set up servers or maintain infrastructure by yourself. Azure Functions focus on event-driven scenarios and provides the on-demand compute resources needed to run your applications and continually update infrastructure. And at the same time, Azure Functions are also on pay-per-use billing model. So when you are on a Azure Functions consumption plan, you pay for it only when you need it, which also helps you save on costs. You can use Azure Functions to build web APIs, respond to database changes, process IoT streams, manage message queues, and many other scenarios. It supports multiple programming languages such as C#, Java, JavaScript, Python, TypeScript, and PowerShell, with the possibility of getting extended language support for languages such as Go and Rust with a feature in Azure Functions called Custom Handlers. Please let us know what you're working on with Azure Functions.
Three, two, one.
Here we go!
I use DevOps every single day when I'm deploying into Azure. Whether it's different tooling like Azure DevOps or GitHub and GitHub Actions, I'm deploying into Azure continuously with continuous integration, continuous delivery, and using tooling like infrastructure as code. DevOps is part of my everyday life.
I use DevOps every day to solve complicated challenges that our enterprise customers are facing. And I also advise them on some of the best practices in the field.
I help customers, partners, and organizations see the value of working with DevOps, including Azure pipelines and GitHub Actions.
I use DevOps every day, from planning work to cutting code in the cloud to CI/CD and then monitoring what's in production.
I talk to customers every day about how DevOps culture, the right processes, and DevOps tools like GitHub and Azure DevOps will empower their organizations to become high-performing DevOps organizations.
I'm using DevOps, Azure DevOps, and GitHub primarily to run pipelines for my own demo environments, and also training customers almost every single week on Microsoft DevOps solutions.
It's our source of truth for live streams and shows and events that you might find on Microsoft properties such as Learn TV, Twitch, and YouTube channels just like this one.
I use DevOps security, also known as DevSecOps, to deliver software at high velocity securely by incorporating security tooling and automation throughout software development lifecycle.
Our vision is spreading the power of DevOps culture. Our mission is to solve the hardest problem in DevOps, to accelerate DevOps culture.
I use it for my streams when I'm creating content for the community. And I also help development teams within Microsoft create their projects. Whether that's an automated pipeline or whether it's issue tracking, DevOps is such a powerful process and it helps in every single aspect.
DevOps has allowed me to change my mindset and change the way that I approach planning my work, structuring the execution of my work so that I can be more iterative and more frequently learn from what I'm doing so that I can continuously deliver that value in any aspect of my working life.
I use DevOps every day to enable our customers to plan and track their work, to collaborate effectively with team members, and to use reliable tooling to deploy solutions in an automated and consistent manner.
I use DevOps every day to deliver content to developers via Microsoft Learn and Docs. I also use DevOps to scan for vulnerabilities, for malicious code and for outdated code on my projects.
I use DevOps every single day by leveraging GitHub Actions and advanced security to demonstrate to customers how to build out secure software development pipelines and how to take an idea all the way into production securely.
Whether you realize it or not, you're probably using AI in your daily life. Typically, AI focuses on analyzing data to be used for things like translations or predictions. But there's another type of AI that you might have learned of recently called generative AI. Generative AI uses algorithms to analyze existing data, such as text and images, to then make new content. Now you can use AI to create entirely new images with DALL-E in Bing Image Creator, or generate code suggestions with GitHub Copilot. But AI is getting put to work outside of work by helping you draft things like a dinner party invite or an itinerary for a 4-day trip to Mexico City. To get technical, this all happens because large neural networks that work together like neurons to pass along information have been trained to analyze and recognize patterns within data. So let's try it. I, a person who entirely lacks musical talent, asked Bing Chat to help draft lyrics about this topic. It searched for information on generative AI and on pop songs and created this.
Generative AI can make anything, from text to images to sound.
Hello everybody and welcome back. Now, I sometimes find 10 minutes goes really quickly or sometimes it goes really slow, and that one went super quick. I hope you enjoyed the video and I hope you enjoyed some of the services and some of the teams that we have all around the world here at Microsoft. It's fantastic to be a part of them and it's fantastic to work with them. So, what are we going to get into next? Well, as per the agenda, we're going to be doing some coding, and we've built a demo application which is a 3-tier application. As you know, we have the front end, the server, and the database, but at the moment it's broken. At the moment, it doesn't transmit any data, and we're going to fix that for you, and we're going to help explain how and why. Adelina, let's have a look at some of what we've built. What's this? Let's talk through it.
I've built this amazing front end. I'm a back-end engineer, by the way, so please don't be upset for what you see. And what it allows us, our demo application is going to allow us to introduce ourselves. So people can write their name and the country that they're in right now, click submit, and then we'll have a list of attendees. And all of this will showcase the power of the community that we have here today, and we wanted to show everyone that as well.
Exactly. So in the break we actually had a little cruise through the chat and saw so many of you and saw some great activity, please keep it coming. Keep the questions coming. We love them, and we will definitely be going over them at the end of this demo. But what we have here, if you've ever seen me on a live stream before with Microsoft, I've always asked you, tell me in the chat where you're joining from. I deliberately didn't do that today because this is what I want you to do. So in a moment, when we get into the demo, I'm going to get you to go on here and we're going to see from where in the world that you're actually joining from. Now, I trust you to tell me the truth. Alrighty, so what is this system? What is it doing?
Yeah, so what you see here is a very, very simple system, but it will give us the hands-on essentials that we were talking about for building a full Go application. So you've got the front end and the server, which are both deployed within the same Azure resource group. And the server is relying on a Cosmos DB database to save all of the entries that people will be writing into the front end. Now, the front end and the server are communicating via HTTP, so we'll be seeing a lot of HTTP work, and they are communicating through JSON, and we will see how to marshal and all of that as well.
Exactly, so an important point to mention here is the Cosmos DB that we're using. So Cosmos DB is an umbrella, and it has multiple tracks inside it, so we can use different databases or different database types. We have deliberately chosen MongoDB. We've chosen this because it is really widely compatible. It is a document database and it allows us to, we don't really worry about tables or primary keys or anything like that. Of course, I know we do have certain aspects in a document database such as that for ordering, but we're not using that today. We are just using MongoDB as a collection for all of our data. We don't need to worry about all the organization internally. So, the server. What is the server? Well, as we've expressed already, this is a net HTTP server. We're just using the standard library. The only third-party import that we've brought in is Mongo and the MongoDB package. We've got two routes that we're going to be using. We're going to be using a GET and a POST. Now we're going to get persons, so this is a RESTful API, and this is going to return all of the people, such as yourself, that have entered data into the database. Then we're going to use a POST. And this post is going to post a person to the database. So when you tell us your name and the lovely country that you are from, this is going to create a document in our database that we can then pull with the GET route. And of course, this is using the MongoDB driver. And all we've used in the file system is a Docker file, a README markdown file, which will sort of scope out exactly what we're doing, and the main.go file. Now, we've heard from Adelina, the main.go file and its sort of visibility throughout the folder structure, and you'll see exactly how that is all working.
So we thought it would be fun to build the front end with Go as well, and this is using the Gopher.js open source project, which will translate Go code that has static typing that allows us to leverage the HTTP package, all of that, and translate it into JavaScript. Also, it saves me having to rejig my brain and write a different in a different language. So what you see here is the outline of the front end directory. So the server has its own directory, and the front end has its own directory in the same repository that we've linked before. So I also use a Docker file for easier deployment. Then we have a main.go file, which will be the entry point of our application. And then I'll have a data service. The data service is the one that will be actually doing all the calls to the backend, pulling the data that I will then display on screen. The index.html file actually contains all of the elements that you saw in that wonderful screenshot. And the scripts.go contains all of the scripts, like the, behavior of the buttons and all of that, which is normally powered by JavaScript, and that is written in Go and then converted using Gopher.js. We also use the JS/DOM library, which allows me to have DOM domain object models, which allows me to model the items or the components.
Yeah, the page.
Yeah, the components on the page, and allows me to modify them easier. So that's all there is in the front end, and we'll have a look at it very soon.
Yeah, so when you told me we were going to be building the front end using Go4JS, I had a bit of an internal panic because I personally have never used it. But after using it now, I don't think I'm going to go back to what I used to do. This is really cool. And those of you who say you can't make websites or you can't do web apps completely in Go, well, hey, we thought we'd have a bit of fun and show you that you can do exactly that. So, Adelina, show us the code. Walk us through the front-end code.
All right, let's have a look at the code together. So what you see here is the front-end directory that I was talking about, and I've already opened the main file. And the main file is a server just like any other using net HTTP, which exposes some routes using the handler functions that we've been using so far. One of them just happens to serve a file, which is our index.html, which is able to display components. It could be anything else, but we're just serving a file, and then the browser can understand and display the HTML file. Now, I won't show you the index.html because it's just the regular HTML. The interesting part is the script. And the script is where I've written everything out that was then converted to JavaScript by Go4JS. And again, this has a main file. It invokes the data service and takes in a backend URL, which is our parameterized URL that we are able that we will connect to the backend with. And then I also parse a countries file because we will have a drop down of countries, and then I add event listeners from line 31 onwards, event listeners which are able to modify the buttons and the things that are shown on the screen. So you see that I'm able, using the DOM package, I'm able to get elements by ID, but I'm also able to have casting and elements which expose specific methods, and this is where I'm able to take advantage of Go's strong typing while modifying my script.
This is really cool, right? So for anybody who's watching this and have used JavaScript, you'll notice that you're seeing some of the really similar syntax being used here. Now again, this just goes straight back to being very user-friendly. And if we look at get element ID, let's take line 60, for example, where we have name. Document.getElement by ID and the name of the input it is. Who would have known, right? I never knew you could do this with Go, okay? I really didn't, and I've certainly learned quite a lot by playing with this because it allows us to stay sort of within context of our own sort of comfort zone. I'm like you, I'm very much a back-end gopher. I definitely don't write front ends. I think that's pretty much evident, I think, but it's pretty cool, you know? It's a really good way to get into this and understand what you're doing.
One thing I'd like to show us, because I'm really proud of it, is so the main meat of this file, of the script, is when it actually, the front end talks to the backend. That's what we're really here for, I think. So what you see here, read user input, which reads from the screen and posts it to the backend, and refresh entries, which gets entries and puts them on the table that we'll see later in the front end. So one thing that we cannot break, even though we're writing Go, we cannot write blocking code because it's still, you know, when the browser will actually run this converted code, it's still JavaScript, and we cannot block the browser. So this is where we had to do some fun work with Go routines to be able to achieve this. So one thing to show is here, for example, the get entries. The get entries method takes in a function as a parameter, and I'll show you why in a moment, because I'm actually following JavaScript's callback mechanisms. So get entries takes a callback function. Then in a Go routine, I call out and get my entries and get my entries from the backend, and if I don't have a callback or any way to send something back, then I won't be able to send things, to tell JavaScript when it's time to update things. Okay, my entries have arrived. It's time to update what's on the front end. So after the remote call, or like the blocking call to the backend, is completed, then I invoke the function. And you see here exactly what I was talking about. You see go routines, you see functions as parameters, and it's all the stuff that we demonstrated earlier.
Exactly.
The post entry is also done in a Go routine, because we have to also not have a blocking call. In the case of an error, usually I would alert or block something, but because this is a demo application, we're only doing it as we're only logging an error instead.
Exactly. So let's have a little look at some of the other code that we have in there. So I think it's amazing that you have a Go routine. It's fantastic that you have all of the meat of the front end essentially written in Go, and is able to produce this for us. Now I know you had great fun playing with this for sure, and I mean it may look it may look really advanced if you're new to Go, but we're sure you're not. It is not, okay? So the fundamentals of this happening, where we've got the poll, where we are grabbing the data, where we're sending the data, absolutely fantastic that it's written in Go. And I absolutely love it. And I just especially like
we had such
the
fun.
DOM, right?
Yeah.
We really did. We had great fun sort of managing this and playing with it. So if we head back over to the slides, we are going to then show the server. So the next thing we're going to do is jump on into and implement the server. Now, I think now is probably a good time to check out the Azure portal, because you think, Liam, Adelina, that's great, you've written this wonderful demo, where's it hosted, what are you doing? Because so far you've just showed us everything locally.
Yeah.
Well, let's head over to the portal. In here, we can see that I've logged into Azure. So this is my Azure account. Now, what we've got, we have got a Tech Days demo resource group. Now, for those of you who don't know the tier models of what's really going on, we have a subscription, which is my subscription. And inside that subscription, we've got resource groups, much like we saw on the diagram a moment ago. In that resource group, I have got a whole bunch of resources. Now, we have got a server in Azure App Services. We have got an Azure App Service plan, which allows us to price our services accordingly. We have got a Cosmos DB, which is the database that we're using today with a Mongo sort of domain within it. We got a registry. Now inside that registry, we have got some Docker containers. So much like Adelina said, hey, we have a Docker container over here, as you casually said, this is where they're being stored. We're storing them within a registry within Azure Container Registries. And then we've got the front end. Now that front end is Adelina's front end application, which talks to the API server. So as you can see, we have deployed an API server and a front end in Azure App Services. Two different components of our architecture in the same service, on the same service plan, allowing us to talk to one another. Then we've got some webhooks. Now these webhooks basically allow us to talk to the registry. Now that one there is the front end, and this one here is the API server. So that allows us to continuously update our app services with the latest container that is being built. So let's have a look at the server code, shall we? Let's implement the server itself. What do we have? Inside here, we have got a Docker file. Now this Docker file is a multi-stage Docker file. Now for those of you who don't know what a multi-stage Docker file is, it basically uses the main image, Golang, as build, which means I'm pulling in the big Golang beefy image to build the application and package up the code. But what was the issue that we had with this as one image?
It was big.
It was massive. It was about 450 megabytes, I think. Now, let's think about costs for a second. Not money, the costs for data transfer. If I want to send that container to Azure, to a container registry somewhere, it's going to take time. Time is money. We're not going to want that. We want this to be as small as possible. We want this container to be that big, not that big. So we used multi-stage we used an Alpine image, which was a Linux image, and we're just moving over the essentials. So we're just moving over the server directory. We don't care about the README files. We don't care about the license. We don't care about the workflows or the front end at this point, because this Docker file is just for server. So we built a binary in the build image, and then we copied it across. Now that binary is going to be tiny. This is part of being cross-compatible or cross-platform compatible. And then we spin it up. The entry point is /API server. So that's what's happening with the build image.
And we've built the API server in the previous stage and copied it on line 21. Exactly. So now we can just throw away everything Go related, because our Go binaries can just run by themselves.
Exactly. It's all encapsulated within one binary, which is pretty cool, right? It's small, it's lightweight, you can throw it wherever you like, and it's a Linux binary. I mean, if I was running a Windows server, all I'd have to do is just put .exe on the end and have it as an executable. It's that simple. So let's actually have a look at the server code itself. What do we have? Now, I've collapsed the functions to make it easier to read, because I appreciate it is going to be quite a bit of code that you're going to have your eyes fixated on for a moment. So we've got a person. Now this person is a struct. Now a person is going to have a name and a location and an ID. Now we have an ID in here because that is what we're using in the database to identify it. It's an identification number. We still need that. We can't just throw a document up there with no ID. We need to give it something. But we've got BSON and JSON.
What's going on with that?
What are these? Well, when you're structuring data and when you're looking at marshalling and unmarshalling with JSON or BSON in this format, so BSON I believe stands for binary, and that is just a way of us identifying what their name is and what they actually look like in the data. So you're not often going to see capital letters in JSON data. It's usually lowercase when you see it, right? So you specify that this is what it's going to look like. So JSON is going to be lowercase name in the data, and again for BSON. But we also see this other cool thing, omit empty. What does that mean?
That means, shall I answer?
Yeah.
The omit empty tag means that this will be omitted or not sent if it's empty.
Exactly. So it may or may not be there, and it's not going to fail if it's not. So we're allowing it to be empty should we want to post something which doesn't have an ID.
There is one dependency here, which is you set the name of the JSON files in your the JSON fields set in your person struct, and they have to match over on the front end, because I won't know what you're sending me, but I'll be looking for these tags. And you could name on your end, you could name the person struct and have like fields and whatever names you want, and then export them in the common vocabulary that we've settled between ourselves.
Exactly. It's an identifier, a common interface, should we say. So let's minimize that struct. What's going on in the main function? Well, we have a connection string. For anybody who has used MongoDB, you need a connection string, a collection name, and a database name. Now that are the identifiers that you're always going to see when connecting to a database, or at least in our instance, that's what we have. We've used these as environment variables. Why have we used environment variables, and why have I not just hard-coded that, Adelina?
Because I want to write code once, and I want it to work in different environments.
Exactly.
And environment variables allow us to set different values and pass it to our function, or like our runnable, and then use them later on.
Exactly. The other bit that I want to add on there is security.
Oh, yes.
So security, when we're using environment variables, this connection string, I don't want you all to see, because it has got my API key in, my connection string. It is the bit that I need to keep secret. So we have to have them outside of our workflow. We need them to be away from the public eye. We need to keep that secret. So that's why we're using this environment variable. But what you did say, Adelina, is the next part, which is when we're using the database name. I don't mind if you know what my database name is. I don't mind if you know what the collection name is.
Oh,
but I do mind if you know my connection string. Because with all 3 bits of those data, that triangle, that trio, you can compromise me. And that's not what we want. So once we have connected or got our connection string for the database, we are going to look at client options. Now, this is where we're able to connect to the client. This is where we're going to be using the URI, which is the connection string, and this is going to be the foundation of our connection to this database. Now, we're also using something called context. Why are we using context? What is context? Can you help me explain context?
So context is an inbuilt type in Go, and it is designed for cancellation, timeouts, and request scoped variables. What we see here is on line 33, we create a new context, and it starts with a timeout, so a 10-second timeout, and that is how long we're going to allow this main function to live. Because remember, we're in the serverless world, and we don't want things to run too long. Then from here on out, if this context times out, every other function that takes in this context will be able to stop executing as well, allowing us to save resources. A secondary usage of context is for us to send IDs or other things that will help with monitoring and allow us to put together a call stack for how our request has traveled. So for example, if I had an ID and I could put a context on the front end and you would put the context with the ID on the back end, then we could match together and see what happened throughout our system.
Amazing, thank you. And with that, we actually pass that into the mongo.connect function. Now, Mongo needs all of this information because of the persistence that we have, that we're running with. We don't want any loose ends in our data. We don't want any loose ends in our code. We certainly don't want it to be insecure or have any memory leaks. So this is a way of keeping it all encapsulated within one scope. And the next line is calling the Mongo connect down here. And this is passing the client options, so our connection string and the context, and of course our lovely error check that you'll always see when you're writing code
error handling.
in Go. Exactly. And we're using the great library log, and we're calling it fatal. So that's going to throw a nasty error or a lovely readable error for us, which is not very good if it fails.
Oh, and remember, usually context is the first parameter, like you see here with the Mongo Connect.
Good catch, thank you. Then we're going to print out to the terminal that is connected. If everything goes okay and we've passed everything through, nothing's failed, we get a printout to the terminal. It's always good to have feedback, right? When writing code like this, it's always good to have feedback as a user to know where your code is up to. It means you don't have to always use breakpoints and have to sort of step through it line by line when things go wrong. Now, we somewhat spoke about handler functions or handle functions. This is where we are calling different routes. And this allows us to call or have a RESTful API which allows us to pass data through and get data back. Now, this is our handler function for this demo. We have got a post, a get, a post, and an options. And of course, we have the default, which is an error. So if none else fails and somebody tries to throw deletes in, well, then it's going to throw out an error because we're not accepting deletes. That is as complicated as this handler function gets. Everything else you have seen. So we have a function delete, but nothing's going to happen with that right now because we don't actually accept deletes. And the final part of this main function is actually starting up the server. Of course, we have feedback where it tells us it's listening on whatever port it's listening on, and then it spins it up with HTTP listen and serve. That's going to allow us to connect and talk with our database. So let me go and minimize that function to make it a bit easier for you and I to read. What's the first thing we're going to do? The first thing that we want to do is create a person in our database. So we have a function called create person. Now, admittedly, we've got quite a bit of code that's commented. Let's start with line number 1. What do we have? We have got a variable person. Now that person is, of course, the struct. And we're initializing this right at the beginning of create because it allows us to define exactly what we want to be posting or what our data is going to look like. Then we have a JSON, a new JSON decoder. Can you help explain this? What's this doing, this part?
So from lines 87 to 91, what we will be doing is, given the JSON inside the request body, which you see there references our body, we will decode it into the person struct that we've declared on the line above. And the reason we pass the pointer as the and person is because we will be writing to this struct and we don't want to pass a copy to the decode function. If an error occurs, we know that probably we were passed a bad formatted JSON in the request body, and this is why we will be returning an error with a 400, which is the status bad request that you see there. It's really good that you are handling all the errors. And the JSON, this is the way that we will handle unmarshalling for all JSON input. So always use a struct because it gives you that type safety that we were talking about, as opposed to handling it as a string and parsing it or something like that.
Thank you. So the next part we want to do now is an ID. Now we've kind of already mentioned we can omit that, we can have it, we can not have it. We want it. We want an ID. We want to be able to tell who is who in our database. So we're going to do that by having person.id. So we are accessing the struct itself, so an element of the struct, and it's going to be a primitive.newObjectID. That allows us to create a unique number, a unique identifier for this person when we create them. So every time we hit this, no one's going to have the same number, no one will have the same ID. Then what we want to do is talk to the database. So we've told our program we want to create a person. We've told the program what the person ID is going to be. We've created that. And then we just need to take in the rest of the information, the name and the location. But we also want to talk to the database. We want to make sure that we can send this request to the database that we have. Like I said, we have a MongoDB collection, and we want to do that by specifying a collection, so a variable called collection, and we're going to give it the name of a MongoDB database and MongoDB collection. Just in one line, we can just grab the two environment variables that we have that we specified, and we can pass that through.
We've received a question about JSON serialization and deserialization, which I think would be interesting to answer now.
Let's go for it.
So is there a way to serialize and deserialize the JSON so that it picks the struct's field names instead of having to retype them as strings?
I believe it does it by default, actually. You don't actually need to specify the JSON or the BSON at the end of a struct. You can just grab them, and it will just take them as a default. That's what it falls back on.
That is absolutely correct. So if you don't specify them, then the default will be the name of the field. In our case, would be like name with capital letter. But as Liam said, that's not usually seen in JSON, and sometimes we might want to omit something or rename it. Another thing to remember is that JSON serialization and deserialization, or marshal, unmarshal, only works on exported fields. So if you have unexported, I said private, if you have unexported fields, then this won't work.
Thank you. I think that answers the question, hopefully. So, where were we? So we're at the collection. Now we want to insert a new person into the database, into the collection that we have. Okay, so what we're going to do is we're going to call a function on collection called insert1. Now let's uncomment this line and see what it's doing. We didn't really touch on this, did we? But if we're looking at an underscore in code, when you're calling a function, because you can have multiple return values from any function, this will just ignore the first return value. So in this instance, we don't mind what the return value is here at this point. We just want to insert something into the database and only catch it if it's an error. So if anything else happens, we want to catch it. Otherwise, we know it's a success. So we're going to call insert1. And then again, we're going to be calling context.background, as Adelina explained a moment ago. And then we're going to be passing through person. And that is the data that we've modified in our struct. This is the copy of it that we're going to be posting to the database.
And in this case, if an error occurs, we're using the 500, the internal server error, because at this point we know it's valid JSON and something's gone wrong on our end.
Exactly. So we can kind of step down the codes, and it helps us debug, actually, if something goes wrong. It helps us debug and find out where in our system this is happening. And I guess the final thing that we really need to do is to return it. So what we're going to do is we're going to uncomment this code, and I'm going to comment this final line out. I don't care about this. This is just a string to tell me it's not in use for the function. All we're doing here is setting a header and saying that the application or the content type is going to be application JSON. And of course, we're setting the character set, UTF-8. And then we're going to set the header, http.status created. So that's an A-OK for us to say that worked. That's what we're going to be returning. And then what we're going to do is encode it. What does this line here do? What does line 109 do, Adelina? What's an encoder? We've spoken about decoding.
It's the opposite operation, right? So what it does is it takes in the W, which is our response writer, and it under the hood this uses some interfaces so that it makes it easy for us to either write to the response or to something else, and then we encode the struct that we've just created. We encode a new struct. Sorry, it's an anonymous struct that only takes an ID, and we send the ID back. So this is a normal kind of RESTful response. Once you've created something, I'm not going to return you the full payload, which might be big. You just get the successful ID that you've now been assigned for your new resource. But if you don't pass the W that you see here on line 109, then you won't be writing to the response. So that's a very important thing to take note of.
It is, and I'm glad you touched on the payload size there, because the eagle-eyed of you would have noticed we haven't explicitly spoken about name or location in this function. We're taking it as an encapsulated body, which is going to be within this encoded JSON that we're throwing back. So that's how we're working with the name and location when we're creating a person. So let's go ahead and save that file. Now the next function that we want to create is get all people. So getting all people does exactly what we want it to do, or says on the tin rather, and it gets every document from this database. Now again, I've commented out the code, and all this function returns so far is root not in use yet. That's all it returns. It's just a print line. It doesn't even show in the console on a browser because we're sort of formatting, or you're formatting on your front end JSON or struct, right? So this just says, error, can't decode this, don't know what it says, blah, bit of an error. So let's walk through it line by line. It's a little bit different to the function above, but the first part stays the same. So we get the MongoDB connection from the client. So again, we're grabbing the database name and the database collection, and then we want to find all the people inside it. How we do that? Well, we're going to have a variable called cursor and error. This time we do care if an error is returned because we are getting from the database as opposed to posting and firing and forgetting. And we're using your favorite friend, background or context.background. But this time we're going to be passing in bson.d. So let's go in and comment this and see what this is doing. So, like I said, we're grabbing it, passing in background, passing in the bison or bson, and catching an error if it occurs. Then we have a defer. Now a defer is our favorite friend to stop memory leaks and to help close connections when we're dealing with databases, especially when you're getting from them. Because if you're consistently polling a database, it's going to be expensive money-wise, time-wise, data-wise. It may even just run up a free trial that you're running. You don't want that at all. So we want to defer the closure of this connection. And with that, we're going to pass in background. And again, it's this whole consistency of having a container in scope that we know about, and background and context holds that, knows where we are in the program, what we're doing. And at the end of this function, should this complete to execution, our desired execution, this will then run and close. Once we have got back our data, here's the fun part. We then want to, I guess, serialize it, right? We want to put it into a data struct. We have person. We know that we're going to be getting back name, location, and an ID. So we're going to go and format that. So what do we do? Well, we're going to, first of all, have a variable called people, and in the struct type of person, which is at the top, Again, like I said, ID, name, and location. And then we want to run through this. We want to go over this. Okay, so we have a for loop. Now, do you mind explaining what this for loop does, Adelina? Let's walk through it.
So at this point, the database doesn't know anything about our struct, right? Like the structs only exist in the context of or in the scope of our application. So what we need to do is we need to tell it, give me the next payload, so like the entire row, I suppose it would be, and let's try to decode that. And then we make use of the decode function in exactly the same way that we've seen before, where we took it from the request and then marshaled it. So what we're doing here is the same as what we saw before. In the case that we can't decode, again, this is data that's come from the database, not from the user, so it'll be an internal server error, maybe something went wrong, or maybe we've received data that we weren't expecting because we've passed some bad environment variables or whatever. Then these errors will indicate that something's gone wrong with our system.
Exactly, and this is sometimes where I see, I'm guilty of this too, been a little bit lax when it comes to error checking and sort of security, I guess, when we're dealing with internal systems. Now, because I'm talking to a database and I personally know what's being thrown back to me, or at least I should always get the ID, name, and location, therefore I may be a little bit lax sometimes and not have to check for certain things, certain variables, certain data sanitization. Not something which I've, should be doing. So it's always imperative to stay with that rule of, you're doing it the right way once, continue and follow through your entire code base as you wish to go on. So as we've seen here, we're erroring with a status internal server error if something does go wrong.
Well, one thing to mention about decoding is, let's say that the database was returning you 5 fields, but you only wanted to have 2, like for us, name and location. So the decode will only decode the data that you've specified in your struct. So that makes it easy for you to do subsets of data and then handle that.
Perfect. So the final part of getting all people, final part of this function, is to return it to Adelina's front end. So after all, this is an API server. I'm not going to be reading this. I don't want to read this. I might read the logs, but I don't need to. So let's go and uncomment those bits of line and remove that final line there. Let's save that file. So again, we're setting the header to the content type to be JSON and the character set to be UTF-8. And then we're throwing back a new encoder with the writer, and we're encoding that as people.
So at this point, what we're going to have is we're going to have an array of JSON payloads, because we have an array of a slice of person, and we'll be returning that same encoded payload for each. There will be the same structure of payload with the different data for each person.
Wonderful. So I've saved that file. Now let's just go and check that there's no errors that we can see. So there's nothing in here that is alarming. Now I'm not going to deploy that straight away. And I'm not going to deploy that straight away because I want to show you what's going to happen when I do. So let's head back to the slides. We have got a pipeline. So to prevent me from having to build this Docker file locally, tag it locally, push it up to a registry, hoping that something happens magically in the cloud, I'm actually going to do this automatically. Now this is part of the DevOps lifecycle. Automation, making our life a little bit easier. So when we were building this, we were constantly changing the code, we were constantly changing the inputs and outputs. Every single time we did this, we both had to rewrite it. And we had to redeploy it, or rebuild it and redeploy. It was a bit of an arduous task, should we say. So decided to use GitHub Actions. Now GitHub Actions is a fantastic tool that you can use, and it will use runners and it will build your code in containers and deploy it for you by signing into Azure. So what are we doing? We are grabbing that server directory, and the workflow will run only within that server directory. I don't want to change, because we're all in one single repository, I don't want to make a change to the server and push it to my branch. And when it's merged into the main branch, I don't want that to then build a new Docker file for the front end. That would be pointless, right? I don't want to build Adelina's front end and redeploy that every single time I make a change to the back end. So I specify server directory. And inside this workflow, we are going to build a Docker image. We're going to tag the Docker image. We're going to log into Azure with my account. I've given it access. We're then going to log into Azure Container Registry, another service that we're going to be using. And then it's going to push that Docker image to the container registry. From there, we've got a little checkbox on our app service, which will allow us to do continuous deployments. So let me show you in the code what this workflow looks like.
We have some questions.
Yep. We should answer them.
We should. I'm going to tell you. So there's a question about how the connection to the database is managed.
Yep.
Are we opening a connection just one time and share it through the different requests, or how does that work? Especially keeping in mind, I think the confusion is coming from the whole serverless.
Yep.
Yeah. So
at the moment, we are connecting every time that we are running this route. So every time that we make a call, we are opening a connection and closing a connection, because that's all we need to do. If we were to leave a persistent connection open, you are going to end up with memory leaks. Your program may or may not close it properly. You may have a security vulnerability in there. Mm-hmm. So say I'm a bad actor and Adelina has opened up this connection. She's made a call to the database. She hasn't closed her program. It's still running somewhere. What happens if I get wind of that and I'm like, oh, I can now compromise your database because you've left your connection string there. I know your database name and your collection name. Well, then you're going to have a bit of a problem. So every time that we are making a call to the database, we're opening a connection and closing a connection. At least that's how we're doing it in this application. Now, it doesn't mean it's not the only way to do it. Of course, there are scenarios when you would have the opposite. But just for us today, this is the way we're doing it.
And when we're fetching things from the database, is there any risk to mix any data that we're receiving?
So this was kind of this is what I was trying to allude to when I was saying, being an internal server, I know what's coming back, but no, you shouldn't be lapsed at that point. You should always have a structure in place. Yes, you know what's coming back. Yes, that's what you're expecting to receive, but no, you shouldn't then allow it to, if you receive something else, to just ignore it, because that could be a bad actor in your database. It could be a bit of somebody trying to do something nasty. It could be a code. So no is the answer.
But you haven't specified a database schema or anything like that, have you?
No, we haven't needed to do that with MongoDB, because the document DB itself, what we've essentially let Cosmos DB manage all of that for us.
Yeah.
So whenever I made this first initial push to Cosmos DB with this connection string, I didn't actually create a database. I didn't create a collection. I made my initial request, and it went off and created it with those names, as you'll see very shortly.
That's really cool. There's some other questions about the deployment, which we hope we'll answer very soon. So let's go back to what Liam was talking about.
Okay, so using GitHub Actions workflow, we can see here on line number 1, we're giving it a name. Now this name is to build a Docker image and push it to ACR, Azure Container Registry. On line number 3, we're saying on a push to the branches of main. Okay, so you can have many branches. You could specify dev, prod, pre-prod if you want to, prod being production and pre-production. And then we have the keyword paths on line number 6. Now this is a really important part, and I kind of mentioned it a moment ago when I was saying I only want to run this if a file underneath the server directory has changed. That's what those two asterisks stand for. So any file or subfolder underneath server that changes within Git and GitHub, it will only run if that happens. Otherwise, if Adelina was to make a change to the front end, the pipeline wouldn't need to run. We don't want to for this one. She'd have her own pipeline. Not that we've implemented it, but she would.
In all fairness, this is a bit of a Frankenstein.
It is.
Because normally you wouldn't have the front end and the back end together. But, this kind of specification gives you a lot of flexibility of what you want to build and when. For example, if you had feature branches instead of main, then you might not want to build or whatever.
Exactly. And this workflow dispatch line on line number 9, which looks like it does absolutely nothing at all, does have a very important use case. Now, of course, this will run automatically when I push to the main branch. However, workflow dispatch allows me to run it manually from within GitHub. It's an important bit of code. Doesn't look like it does much, but that's what it allows us to do. Then we have some environment variables. Now, admittedly, these should probably be environment variables kept out of a workflow, but for the sake of this demo, I wanted to have them there so I could show you the naming convention that we've used and what we've called it. So we're tagging it V1 for version 1. You know, we may go on to create another version of this and call it V2, and we can deal with that later down the line. But for this, we've called it V1 rather than latest. I'm not a fan of using latest when we're in deploying applications. Then we've got server, and we've called the server the Tech Days Demo Registry.azurecr.io. That is our Azure Container Registry. That's what I've logged into. That's what my environment, that's what my credentials allow me to do in GitHub. And of course, the image underneath it is called Tech Days Demo Container. That's what we're calling the container or the Docker container that we have built or that we're building. Then we have jobs. Now it is a plural because you can have many jobs. And underneath here, we've got build. And all I need to do is build. We could have test under here as well. But we've got build on line 17. And inside that build step, we are then going to run a container. We're going to run Ubuntu latest. And we are then going to check out actions. This lets us, well, that tells GitHub that we're going to be running an action, a GitHub action workflow with this container. Then we need to go and set up Go because, albeit Ubuntu latest, cool image, doesn't have Go installed. But fear not, there is an action available to do that. The cool thing with GitHub Actions is they're all just GitHub repositories. So as you can see here, actions/setup-go at v2 is a repository somewhere. And that's a version 2 of a repository that sets up Go on or within a container in a workflow. We're specifying version 1.18, and that's just the version of Go that we have running here.
What's also really cool is that you don't have to redefine these things. These things are there, they exist, you can use them in different code bases. If I go to work for another employer, I'll be using the same stuff. And it's also very, very simple. You see this kind of like YAML indentation. It's very, very simple to set up something that's actually quite complex, which is the CI/CD pipelines.
Exactly. And then the final steps that we have is to use Azure. We need to log into Azure. Now to log into the Azure Container Registry, we just do a Docker login. It's just an extendable part of Docker login that we're using to log into our registry. And of course, we're calling the environment variable server, which we declared at the top, and the username and password, which is a secret. And I'm going to keep it a secret, and it's stored in GitHub. It is for private eyes only. But this is how we access those variables. We've got env for environment variables, which we can specify either in the repository or in the code itself. I've done it in the code for sake of ease for this demo. And we have the secrets period for secrets in GitHub. And the final step is run. This is the important part because without run, this would do nothing. So on line 33, we have run, and we're going to cd into the server directory because the workflow is at the root directory of the project. It's in GitHub/workflows, and then we have deployment.yml or deployment.yaml, however you want to say that. So it knows where it currently is in the root of the directory. We need to go into server because I need to build this Docker file right here. So what are we doing? We're going to do some Docker commands. Docker build, and the period there stands for any Docker file within that directory. We're going to tag it with the server name, which I've specified above, the image name specified above, and the tag specified above. Then all we need to do is push. So we're going to do a Docker push on line 36, the environment variable server, / the image, and the tag. That is all we need to do. And that will push
and
it.
these are the same commands that you'll be running locally to test it out, like Docker build, Docker, well, not Docker push locally, but yeah.
Well, the amazing thing is, this is just a Linux terminal at this point. We're just coding within a terminal, but within a file. They're commands that are just popped into that container. So, should we go and have a look at what's going on? Should we add them?
I think it would be nice.
So we can see that I've modified the main.go file. Now, I'm sorry, I'm going to push to the main branch. I know I shouldn't, but we're going to do it. So we're going to do git
Living
commit.
on the edge over here.
Oh, we are. We certainly are. So git commit, and we're going to say fix production or fix prod to production. We'll do that one.
Did we forget to add?
I did. I did indeed. I forgot to do a git add, everybody. There we go. Now I can do a git status and see it's actually staged. There we go. Perfect. Thank you. Fix production and a git push origin main. Let's head over to GitHub and see this in action.
So the reason we're fixing production is because before we had the code commented out.
We broke production, which is there. But as we can see here, this is currently broken. This is what it looks like. If I click refresh, it's currently broken. Like I said, this is what it looks like. So if we head over to the Actions tab in GitHub, we can see the workflow happening here. The previous one was breaking production, as you can see. So let's dive into it and see what's actually going on. So let's look at the logs. So we can see here it's set up the container, it's set up Go, it's logged into Docker or logged into Azure Container Registry, CDing into the server. We're building the container as it stands. So we've got step, just what you'd see locally. It's just a terminal. And it built it successfully, and now it's going to push it.
So these are the Docker steps.
Yep. These are the Docker steps. That's the action complete, everybody. And it looks like it completed with a big green tick, which now means we can head over to our app service, the API server. We can go and check out the logs and see what's going on.
This is very exciting.
This is the tense part, everybody. Here we go. And we can see here at, that is 11:35. That looks like it's the old logs, but it's just going to have a warm up. It's going to need to maybe take a minute or two to push. We may or may not get a notification in here because I've just started the log stream after it pushed to container registry. But what I can show you actually is the deployment for CI/CD by looking in the deployment center. Oh, it looks like it's doing something.
It's doing something exciting.
There we go. We actually got some logs. Fantastic.
And
well,
here we see the Docker run. Yeah.
Exactly. So initialized successfully and is ready to serve request, everybody. And I'll show you how that happened. So in Deployment Center, on the left-hand side of our service, we have some settings. Now in these settings, it's going to tell this service exactly where to pull the code and container from. We're pulling a single container from Container Registry. It's under my subscription. It has admin access to do this. It's pulling the Tech Days demo registry, so everything that you just saw in that deployment file with the container itself and the version. So I could have multiple versions in here and change it if and as I want to. But this little button down here, this radio button, is the important part for everybody to know, because this allows this service to always pull the latest change from the container registry. Really important to notice that. And it is one of the most fundamental parts of app service because it helps you keep up to date without having to do any of this. So like I said, I would have had to do all this manual. I would have had to do this so many times just to get this working.
I wouldn't have done it manually because I would have forgotten.
So let's go and have a look at our database. Oh, jumped out of here. So let's go to the Tech Days database and go and see what we have in there, because I believe I may or may not have left 3 documents in there for us to see. So let's go to Cosmos DB. In here we've got Data Explorer. This helps us see all the data that we have in a database, what we're doing with it. And we've got Tech Days Demo DB. We've got a collection called Tech Days Demo Collection, and we've got some documents. I hope. Let it load for a moment. There we go. We've got a couple of documents, and we can look at them and see what they are. Keith Legend. He's a legend. That was me, by the way.
We put in some test data.
Exactly. That's test data for you. So what happens if we go and use the front end? So let's click refresh. And by the way, there's 2 refresh buttons because this list might get quite long. One at the top, one at the bottom. And look at that. We can see this happening live. So everybody, if you dare, go to techdaysfrontend.azurewebsites.net. We'll post that in the chat and we will see you have access to it. You can introduce yourself. Tell us where you're from. Tell us what you're doing. Adelina, why don't you do you? Show us you.
So go and click introduce yourself. And here you can write my name, Adelina Simeon. And I'm in the UK, but let's do Romania, which is my native country. So we'll say that I'm Adelina and I'm from Romania. So click submit now, which is the green button.
Click that one.
And what happens now is we don't see the data yet because the update is still happening. So we can't, sometimes if we're very, very fast, we'll be able to see the refresh immediately. But by now, the data should be persisted. So let's click refresh and hopefully I should be there at the top.
Fantastic.
So please let us know where you're from and what in your name, because we want to say hello.
We want to see where you are from, where you're joining from. So go to techdaysfrontend.azurewebsites.net and introduce yourself.
So the azurewebsites.net is coming from the Azure app, right?
It is indeed. It comes from App Services. So if we remember back to my slides earlier, where we have got the little box where you put in your name or the name of the service, that is the name of the service, and this is the standard suffix of the URL, .azurewebsites.net.
So we didn't have to do all of that configuration either. It was already set up.
It was there. It was there already. I mean, you can add a custom domain. By all means, you can add a custom domain. We haven't done this because we're only showing this once, but you can add a demo domain. You can have your website domain, maybe liamhampton.co.uk, maybe adelina.dev. That's the one I was trying to get to. And you can have them on your app services for yourself. Oh, look at this. We've got some cool people joining. Fantastic.
From the UK.
Wonderful. So we've got North Korea. Fantastic. Hello. United Kingdom, we've got Denmark, Italy. Obviously we have Romania, which is you. You're joining from UK, but Romania in spirit.
Wanted to have something different than UK.
We got more. So
there's another person.
Amazing. Alex, hello, Alex from Romania. So as you can see, this is running a 3-tier application. We've got a front end. We have got a server, which is the back end, dealing with all the logistics, and we have got a database. Now there's one really cool thing that I wanted to mention about all of these services that we're using. All of them serverless, which is pretty cool. Okay, serverless, people think serverless functions, just code. Well, actually, no, we have serverless services as well. We'll do one more refresh and then see what else is good. We've got lots of people. Amazing. It's nice to see so many of you
nice. Thanks
joining. And I tell you, I'm very proud that this actually worked. I'm very happy this worked on a live stream. We didn't have a backup or a video, FYI.
And we showed you that it was broken before we deployed.
So it wasn't working, now it does.
It's really nice as well to have like a fully deployed demo and really just see exactly how you can start all the way from the beginning and have it go all the way through.
Exactly. Do one more refresh. Marge Simpson, hello Marge from the United States. Fantastic. Well, it's great to see you all joining. Thank you very much. Let's head over to the slides one more time. And I forgot to do my little diagram here, but as you saw, pushed it to GitHub, GitHub ran some actions, and that pushed it to container registry to Azure App Services. Now, we've already deployed our changes, but we would like to say a massive thank you to everybody that has joined. It has been great fun to be doing this with you over the past, I think, what is it now, almost 2.5 hours we've been here. So, thank you. Anything you want to say, Adelina?
Thank you so much for inviting me to take part in this event. I've had a really great time and it's been really, really fun building something together. Even though we don't work at the same company, I don't often get to do that. So yeah, I hope you've all had as much fun as I've had working with Liam.
This is the power of community. I only met you at a conference, and here we are now, right? If you want to get in contact with us, please do follow us on Twitter or link us on LinkedIn. If you have any questions, I think now would be a good time to take them. And I want to say one shout out. You have written something I believe.
It's not out yet, but I have written a book about test-driven development in Go, and it's going to come out in May. And you know, it's all about like all the test-driven development and how to implement it at different levels of your application. So thanks for that. It's been a lot of work.
It sounds like it. It has been a whirlwind start to the year for sure. It's absolutely fantastic to see this come together. It's brilliant. I'm so happy to be here demoing this with Adelina in the Microsoft Studios. So if we have any questions, we will have a little look at them now.
And don't be shy to message us later as well. If you watch it on the stream, reach out to us on Twitter if you have any questions, and we'll be happy to answer, I'm sure.
Exactly. We're super active on both platforms, so fire away. Question. Interesting how the locations are different. Could you explain why? Why are the locations different on our drop-down list? That is because there is 100 and something countries, and you pulled them from a gist, I believe.
Yeah.
Yep. So it's just a drop-down list, if that's the, I guess, the answer to the question. We have, what else do we have? So we've answered the database connection.
Yeah.
And is there a risk to mix any data? We've answered that one. Liam, any particular reason why GitHub Actions rather than Azure Visual Studio Online? Yes, at the moment, I wanted to run this locally to show you how you can use a local dev environment. Of course, you can use code spaces. Now, using code spaces is a fantastic way to have a cloud-based environment, or I say a browser-based environment, which you can use yourself as well, but it does incur a cost. You need to be careful with the limitations of that one. Because we've been playing with this so much, we used a local environment just to show how that works. Now, as opposed to the GitHub Actions side, there are many other CI/CD tools that you can use. Of course, there's many. We have got, I think another one that I widely use is Jenkins. I think I've used Circle CI, a whole bunch of cool tools. However, this is the full end-to-end dev experience that we have at Microsoft, where we are using Visual Studio Code. We are using the plugins that Visual Studio Code provides with Go. We are using GitHub and GitHub Actions and Azure. So one whole cohesive deployment developer environment.
I'd definitely say that at this point, GitHub Actions is more or less standard. So for example, we also use them at Form 3. And I think most companies that do production code, they'll be using some kind of solution based on GitHub Actions.
Yeah.
Because you can write your own actions as well. It doesn't have to be the ones the built-in ones that we've demonstrated. So there's really a lot of flexibility in the system.
Exactly. And all you need to do is scour GitHub to find, or in the marketplace for GitHub Actions to find plugins for so many different services that you have. People are writing them, companies are making them. It is becoming far and wide and a really good way to keep everything within one umbrella under GitHub if that's where you're storing your code. Of course, we're aware there are other repositories that you can use. This is just one that we're using. Now, I also would like to touch on the fact that the reason why we used MongoDB, and in the code in MongoDB, if I show you the imports actually, if I go on back to the code on the screen, if we look at the imports, we're not actually using anything out the ordinary. We're just using the standard library from line 4 to 10. We're using lines 12 to 16 or 15, Mongo. This is because it is really transferable and cloud agnostic. You could be using MongoDB standalone. You could use a different document database, a wrapper around MongoDB in another cloud service provider. This would still work. This is the purpose. We're not selling this. We're showing you how cool it is that you can do it and how you can write Go in Azure. So I think that kind of wraps up the questions. I don't think I can see any more questions, and if we do, I'll do one final scour through the chat and take it from there.
Yeah, we'll just talk to
Yeah.
people online. It's not. Yeah,
Indeed.
just message us anytime.
Thank you very much, everybody, and with that, we will end the stream.
Bye.
Thank you.